Hello everyone and welcome to William's Workshop. Today we are taking a look at the circuit network from Factorio. This video is a jumpstart guide which intends to quickly show you the basic mechanics in order for you to start making your own circuits as quickly as possible. To start, what even is the circuit network? Well, it's a collection of red and green colored wires and various components all connected together to help manage the automation within your factory. In order to even place wires, you can click the icons in the shortcut bar, use the associated hotkeys, which by default are Alt-R and Alt-G, or my personal preference, which is to add the wires to the quick bar and use the number keys for the slots they are in. Let's get started. Now, if I connect a wire from this constant combinator to this lamp, it changes color. That's because the combinator is set to output a magenta colored signal. All the lamp is doing is using the received signal to change the color of the lamp itself. However, wire does have a maximum limit of about 9 tiles, so directly connecting components only goes so far. To get around this, you can connect components to electric poles to further extend the reach. Right here, this combinator is outputting a red color signal, and this one is outputting a green color signal. You can also hover over the electric pole to see which signals are being sent over which colored wires. All the lamps are doing is the same thing as the previous one, which is changing its color based on the received signal. One of the main uses of the circuit network is the ability to read items from certain containers. You can read from belts, chests, storage tanks, and a whole variety of other machines. If I add either iron, copper, or steel plates to this chest, the displays will then show the items within. This one is showing the iron plates, and if I add the copper and steel plates as well, these other two will also show them. The displays are pre-programmed to detect if a certain plate is greater than 0, and then displaying that plate. It's not an adaptive system, but I'm sure you can make one yourself. However, this video does not cover such a design. This inserter is checking if there are more than 2 plates, and so if I add 3 in, what will happen is one will be moved out so that the conditional will then disable it. Another setup is this: 3 inserters around a chest checking if there are 3 or more items. If so, they will all activate, evenly dividing the contents into 3 other chests. And if the items don't evenly divide, it leaves the excess in the central chest. I have personally used this system multiple times, and I would definitely say it's a useful thing to have. Now, let's talk about the 3 main combinators. There is a 4th one, but you only unlock it until a much later technology is researched, and I honestly haven't played around with it much myself, so I'm just going to stick to the basic 3. This is the constant combinator, which I've already shown you, but a little bit more info is you can select any item from any of these top categories. I only have these bottom 3 categories unlocked since I am in a sandbox world, but you normally wouldn't. These, the generic signals, can be used however you'd like. You could also use flamethrower ammo as a signal, and then you can select the count of how many you want, which has lots of different uses. For example, you can make a calculator. So now this constant combinator is outputting a signal of 10 flamethrower ammo. There's also this, the arithmetic combinator. What it does is perform simple operations such as multiplication, division, addition, subtraction, as well as other. One such example is modulo. What modulo does is it divides the first input by the second input, and then returns the remainder as the output. There are also exponents, bit shift left, bit shift right, bitwise and, or an exclusive or. Those last 5 are a little bit more niche, and I haven't personally used them, but they are there if you do want to use them. There is also the decider combinator, which, unlike the arithmetic combinator, can have multiple conditions with ors or ands chaining them together, which can then be used to detect different conditions. These values here, greater than, less than, equal, greater than or equal to, less than or equal to, or not equal to, can also be found within devices like inserters. You can compare both numerical and signal values. You can also have multiple outputs, which is also unique to the decider combinator. Over here is a nice little contraption. As soon as there are less than 10 iron plates, it will fill back up to 30. Unlike a standard check, simply looking for if there are less than 10, instead of as soon as one iron plate is moved over and it's stopping, this will fill up the output chest to 30. What this is doing is it's first checking if the iron plates are less than 10. If so, it outputs this check signal. It is then feeding the output check signal back into the input, and it is checking if the check signal has already been activated with the conditional greater than 0. It's also checking if iron plates are less than 30. Over here is a simple clock. What it's doing is it's taking this clock signal, which could be set to whatever you want, and adding 1, and then outputting that value. So if it was inputting 0, it would then output 1. If it was inputting 1, it would then output 2, so on and so forth. What this is doing is performing the modulo operation. What this is doing is dividing by 60, and since there are 60 game ticks in a single second, every single second, this clock will loop back around. Once it hits 0, it will then loop back around into the combinator and start all over. What this inserter is looking for is when the value hits 0, then it will activate, transferring 1 iron plate. So as soon as I connect this output to this input, the arithmetic combinators begin rapidly activating, and the inserter will slowly transfer 1 item over from the first chest to the second chest at a rate of 1 item per second. This can be very good for controlling the rate of flow of items throughout your factory. I actually have this specific setup in one of my factories, and it works really well at maintaining a consistent production of items. I hope this video has provided you with some insight into how the circuit network works and has inspired you to start making your own circuits. Now get out there and start making. I hope you have a good rest of your day, and until next video, take care.